on behalf of our institute and also Science Campus Reform, I welcome you, and I'm extremely pleased. It's our 16th Montelius lecture that we have delighted to festival and to feast today. And of course, we are delighted to have you, Erez, Professor Erez Ben-Yosef from Tel-Aviv University. We are all pleased because his country, as well as the entire Middle East, is currently going through a particularly challenging and difficult phase, as you know, and one might even say suffering through it. Let me say in advance that in all these difficult times, we are on the side of the people, also as institute, and within your framework on the side of our framework on the side of science and the scientists. Nothing more has to be said. It's the people and for us also the scientists who are suffering on that situation. With today's lecture, we are also commemorating the Swedish imperial antiquarian Montelius, whose impact on our discipline and the methods, it doesn't work, hopefully it works, yeah. And the methods of archaeology can hardly be overestimated to this day. Montelius was concerned with the entire ancient world and not just by typology. That would be an admissible simplification. He cultivated in his time a systematic methodology and a cultural historical approach that has had a lasting influence on our discipline. Despite his extensive studies on the so-called method, which is the most common one associated with his name, and his comprehensive perspective on past cultures, Montelius, for instance, deepened his knowledge throughout his life by traveling and attending congresses. He remained faithful to his Scandinavian homeland, of course, with many of his studies, and I not want to call all of them. There are numerous works dealt with his region across time, but there was also important work on the Mediterranean and the Old World that we know from him, for instance, on the, as we say, the Orient and Europe, or Orienten or Europa. However, it would have not been possible without his wife, Agda, that you see here as well, who was a well-known Swedish intellectual and feminist. Perhaps her contribution to the development of society was possibly more significant than that of her husband. She was involved in many Swedish philanthropic organizations and became one of first Sweden's leading figures in the field of feminism. Her best-known principle was guiding people to help themselves. From 1886, she also was involved in Sophie Adler-Sparre's women's rights movement and finally took part in the government consultations on equal rights for men and women in marriage in 1912. In 1920, it was finally passed as a legal norm by the Swedish parliament, one of the first countries that did so. So, as always, it's not only the men alone and not also the women alone, it's all of us who contribute and work together. However, Oskar Montelius, as I said, he looked, by help of his wife, by possibly also her support, to a wide range and of course, also social, economic, and cultural historical consequences, but also himself with an awareness of the importance of contact between distant societies and the fruitful exchange with the other. This may be also the leitmotif for this evening, as archaeology sees itself more than ever as a bridging subject between humanities and the natural science. It mediates in methods and terminology and is ultimately forced to be able to speak in a pluriverse cosmos of methods. And this at all applies, and all the more to today's evening speaker. Professor Ben-Yosef is one of those scientists for whom multidisciplinary approach is inscribed in his own DNA, I would say. We find it in many of his projects, not last in the central Timna Valley project, which will be the subject of today's talk. But first things first. Erez Ben-Yosef studied archaeology and geology at the Hebrew University of Jerusalem and archaeology and anthropology at the University of California, San Diego. And it was this studies in San Diego that brought him to Tom Levy then to Andreas Hauptmann, through Andreas Hauptmann to Bochum, 2010 about, and doing work for his PhD, The Oscillations in Iron Age Copper Production and Power in Southern Jordan, that was published in 2010, and presents results of a 6 years field and laboratory research on the copper mines of the Southern Levant, especially from Fenan. His work in Fenan, together with the San Diego team and Tom Levy, I mentioned this, brought to light many new features that also contrasted the older work of the DBM there in this mining region, and also provide valuable insights for us here in Bochum, especially Andreas Hauptmann, Ingolf Löffler, who did his PhD on that topic, and of course myself, to rethink older ideas. During 2010 and 2011, then later on, he carried out postdoctoral research at Scripps Institution of Oceanography. That's nearby the Mexican border. Yeah, if you go down from San Diego to the nice ocean Pacific, then you see this nice institute, which is not so much combined with archaeology and archaeometry, but Erez did his first postdoc there on ancient copper mine of Cyprus, an application which was extremely interesting because it did it together with Lina Cassianidou, which we know here as well, and others on the massive slag heaps there, especially Squariotis. And I remember you standing on these tall machines and sampling this Squariotis slag heap. This was a fantastic work because he discovered, or they discovered, the earliest layers of the early Iron Age, and therefore had a connection with the Southern Levant too. Okay, since 2011, he teaches at the Department of Archaeology and in the graduate program in Archaeology and Archaeomaterials in Tel Aviv University. He has since then authored multiple research papers on archaeometallurgy, archaeomagnetism, Iron Age archaeology, and many more. So if you look on his records, it's about 120 articles. It will take a whole evening to talk about them, which I will certainly not do. And of course, 8 books and edited volumes that goes on his account. And of course, many is related with today's evening. Sorry, you should see this is Erez. Here is in the front. So, okay, his focus is on the Iron Age, but not only on archaeometry, for which he developed new research paradigms that change traditional views. One example, and possibly we will hear about this evening, is a recent publication that earned a lot of interest from the public on the architectural bias in the biblical archaeology that has triggered a broad discussion on the interpretation of nomadic background of the biblical kingdoms. So possibly also what we estimate nomadism as. Mostly we think it's something that is underestimated and something we can leave aside, but of course it is not the case. So anyway, at the end, Erez Ben-Yosef won multiple awards, a research grant, a Fulbright, an ESC Marie Curie integration grant, a Kada Family Award for outstanding research. And of course, he serves in Israel on many duties, for instance, as a member of the Archaeological Advisory Board of the Israel Ministry of Culture. So Erez, welcome again in difficult, troubled time here in Bochum. And of course, now it's the stairs are yours, and we're looking forward to a lecture.
All right, thank you very much, Thomas, for this great introduction. It's good to be here. I'm going to present some of the research we are doing in Timna Valley in this talk. I hope to leave some time for questions and discussions because I'm here mostly for this kind of the discussion, the interaction between you and me. There is a lot to say, and I chose several topics. Some of them are a bit technical because it's the Deutsches Bergbau-Museum Research Institute. So we'll get to that in a minute. How did I get to work on archaeometallurgy? I started more than 20 years ago with studying slag. You will hear a lot about slag in this talk. How do you say slag in German? Schlacke. So I hope everybody knows what slag is. If not, it's the most prominent byproduct of copper production or metal production. When you produce metal, you take a rock, you smelt it in a furnace, and most of what's left is black stuff. It's like a rock. It's very similar to basalt rock, and it's slag, and it's everywhere where people made copper or metal in ancient times. And it's a treasure. It looks like nothing very special. People usually don't put it in museums, except here in the mining museum, but no other place. But it's a treasure of information for many things. I'm going to talk mostly about technological information, how people made this magic of taking a rock and making it into something shiny and useful. But I started with working on slag. You see on the right-hand side a picture of a slag pile in Feinan, a lot of black rock with ash and charcoal. My beginning was with the magnetic signature of this material, developing a dating tool based on the magnetic signature of slag in the region. Slag, when it cooled down, when it is cooling down, it records the information of the magnetic field at the time of this event. And the magnetic field is constantly changing. Even in the last 40 years, there was a major change in the intensity and the strength of the magnetic field in the area of the southern Levant. So slag, if you know the date of the slag, the date of the smelting activity, you can reconstruct the behavior of the magnetic field through time, and then go to some undated material and use this information to date other sites. This started more than 20 years ago when I was a master's student, together with, of course, my supervisors back then, Chagai Ron and Lisa Tox and Amot Sagnon. But this was the first time I went to the south of Israel and to the south of Jordan and collected slag for many different periods. And you can see the curve here. These are the changes of the magnetic field intensity, the strength of the magnetic field from today all the way to about 6000 BCE. This has a lot of information in itself. For example, you see F2 in the middle. This site was published by Benno Rothenberg, who excavated in the copper mines there much before we excavated there. This site was published by Rothenberg as the earliest site in the world, the first place where copper was produced ever. And it started a lot of debate, including with people in the Deutsches Bergbau Museum. And there was a very first debate. He insisted it has to be a Neolithic site. Although some radiocarbon said it has to be Iron Age and the technology didn't fit very well, but you know, every archaeologist wants his site to be the first, the earliest, the best. So he insisted. He heard about this method and he said to me after a lecture he heard about what we are doing, that he's willing to give me some pieces of slag to do this dating method on the slag itself. So it's a very good method because it works on the technological debris themselves. Nothing can be claimed as intrusive or problematic. And I told him, of course, I'm willing to do it, but you take the risk. If it is not Neolithic, we are publishing it. He said, okay, we're going with science, and you can see the results. The results is about 120 VADM, doesn't matter the units, doesn't matter now what are the units exactly, but 120, you see it fits best to about 1000, 1500 BCE. Nothing in the earliest periods is so strong. So this was the final decision about this site. And Timna is no longer the earliest site where copper was produced. If you go to visit the Timna Park, you still see in the brochure that this is the earliest place. And I always argue with the park management that they have to change one word. It's among the earliest, but they don't listen to me. They have the other interests. And this is a different problem. So I went through this Arava, the slag material, and then I joined the American expedition to Jordan. Andreas was an advisor to this expedition, and you can see here Tom Levy. So you see Andreas in 2006, in one of his visits to the field, we hiked a lot together in the landscape, in the desert landscape of Feinan. Tom Levy here is in the front, and Muhammad Najjar, the Jordanian colleague of Tom, are also there. And Feinan, as you probably know, is a treasure for ancient metallurgy. And this pit, this huge pit, you cannot see the bottom of it. It was almost 7 meters of debris, copper production debris, in a site called Khirbet Nachas, was the basis for my PhD. As Thomas mentioned nicely, it was focused on copper production technologies in the Iron Age, based on materials from excavations in Feinan, together with the advice of Andreas Hauptmann. And this is why I was here to do some final lab work of slag, mostly slag. Not only slag, but mostly slag. And this is part of what we are going to talk about. Already in my PhD, I started a small probe in Timna that later on became a big project. Timna Valley, you can see it's next to the Gulf of Aqaba, the Gulf of Eilat. The area between Timna and the Dead Sea is called the Araba Valley. Okay, the Araba Valley, it's the big rift valley. It's a tectonic plate boundary. And in this Araba Valley, Fenan is also located closer to the Dead Sea. So these big copper production regions are located here in the south, in the desert. And Timna was the first to be systematically excavated and surveyed. We know about this place from 1865. The first guy to report about these ancient copper mines was the British consul in Khartoum, who was a mining engineer. And since then, every traveler and explorer that went through the region described this amazing place with a lot of copper production sites. The mines were found much, much later. What the local people, the local Bedouins, the local population there knew is the slag, the big piles of what we just discussed. The mines themselves were much harder to identify, and it took much more years to find them, but they, of course, are located in the valley. And the place is, maybe together with Fenan, probably maybe the best place to study ancient copper metallurgy anywhere, because we are quite lucky here. First, modern activity is very limited, very limited. In Fenan, there was no, except for some prospection, until today, there was no major copper exploitation there. In Timna, there was an Israeli factory there for about 20 years, but luckily it was mostly underground. So all of the archaeological sites are there. In many other places where we talk about metals, the modern activity completely destroyed the archaeology before we realized how important it is to human legacy. In Cyprus, for example, slag, this material was used to pave roads until about 40 years ago. So here it's all there. And in addition, it's in the middle of the desert. So you don't have vegetation like in other places of our colleagues that work in, I don't know, in Thailand and other places, even in Europe. Here you just go down from the bus and you can touch slag from 5,000 years ago or 3,000 years ago and study them and see the material. This is fantastic. And the first to realize it was Benno Rothenberg. You can see him here, who in 1959 started the Araba expedition, investigating the metallurgical remains and the mines of the Timna region. And he was quite a pioneer in the way that he collected in his team a group of experts, mining engineers like Gert Weisgerber from here, geomorphologists, geologists, chemists, physicists, many other experts to understand the technology, to understand the geology, to understand the mine. So it was a multidisciplinary team like you need in order to really understand the technology and the history of the people in such a region. And he was working in the area for many years. And one major discovery of his changed the historical picture of Timna. This discovery is this small temple that you can see on the left side. It's very small, but it was full of artifacts. Because it was destroyed in an earthquake, archaeologists like destructions, disasters. That's why he found there thousands of artifacts that tell us the story of this little temple. And most importantly, there were inscriptions there talking about expeditions of the New Kingdom of Egypt. We're talking about the 13th to the mid-12th century BCE, about 150, 170 years of activity that could be securely dated to the Egyptian New Kingdom. So after he discovered this temple, all previous ideas about connection to the biblical period, to connection to the local kingdoms of Edom and Israel, were completely omitted from the scholarly discussion. When we talk about, the title of this talk is related to the question of King Solomon's mines. This is a really interesting question, and it was asked for the last maybe 200 years or more. there were some suggestions that the sites that we see in Timna were the source of wealth of King Solomon before Rothenberg, but because of this discovery in 1969, 10 years after he started working there, Rothenberg decided that all of this major activity had to be done by an empire, cannot be related to a small kingdom, local kingdom that the Bible mentions that might not even be real. It might be a fictional kingdom that was invented later on by the biblical authors. And here he has a positive evidence for the presence of Egyptians that managed the work, that came all the way here to exploit the copper. It was together with the local people, but managed by the mighty Egyptians of the new kingdom of Egypt. And he argued with everybody, and eventually everybody accepted this picture. That the major, we have thousands of years of history in Timna, but there is a clear, one clear period, which is the peak in production. And most of the sites that you see when you visit the valley are from this specific period. And he decided that these sites, all of them should be dated to the new kingdom of Egypt, to the Egyptian period. And something similar happened in Feinan, even during the work of the German mining museum there. The main activity there was dated to the late Iron Age, during a period of a different empire, which is the Assyrian Empire, 7th century BCE. Okay, so if we're talking about the question of King Solomon's mines, no, I won't go into much detail about this discussion, but just to make things very clear, Solomon, if he was a real figure, is dated to the 10th century BCE, okay, around 960 BCE. His father is King David. King David is about 1000 BCE. It's easy to remember. These are the dates that we need to look for remains from this period in order to try and understand, to assess the biblical story. So David about 1000 BCE, Solomon 960 BCE. The Egyptians 200 years before King David, before King Solomon. The Assyrians 200 years after King Solomon. Nothing in the region was related to the period of King Solomon when Tom Levy and Muhammad Najjar started their expedition in Feinan, and when we started working in Timna. So the first excavation was in 2009, and since 2012, we started a big project. It's called the Central Timna Valley Project of Tel-Aviv University, and we go to the field almost every year. During the winter, because it's very hot in any other period, we continue, we go in the footsteps of Benno Rothenberg to ask many questions about technology, about people. But one of the most important questions we are asking is related to chronology, because already in 2009, we excavated this little site over here. See where the arrow is? It's a site surrounded by a wall, excavated by Rothenberg intensively and published as a New Kingdom Egyptian smelting site. It's called Site 30. Most of the sites in the valley has numbers. And you see, this Site 30, we excavated there. It was in 2009. I wanted to compare the technology from Feinan to the technology from Timna, and we went there. Rothenberg gave us his blessings, and we got the permit, and everything was okay until the results came back from the radiocarbon lab. And all of the dates came later from the Egyptian period, and mostly fall in the 10th century. All the dates fit very well the period of King David and King Solomon. And this is why, when we knew that there is a chronological confusion in Timna, this was one of the main reasons why there was a need for a big project in Timna that started in 2012. And you can see here, this is the Echat temple, the Egyptian temple. And there is a big site here, it's called Slaves Hill. It was not excavated by Rothenberg, and in our first excavation season in 2013, we went up the hill, and we were sure that this is the smelting camp of the Egyptians, because the Egyptians were there, and for sure, they were there for copper, not for anything else. There is no water, it's not a strategic location, They were there for the copper, and this is a much closer site to the temple. And we excavated the slag mounds, and also this site is not dated to the Egyptian period. It's still, it is again dated to the period of David and Solomon, even in a narrower window, only late 11th, mid 10th century BCE. So to make a very long story short, we excavated many other sites. There is about 11 big smelting sites in Timna. We excavated about 6 of them, and others, including Rothenburg, excavated others. Now I can tell you that among all of these 11 sites, only one of them can be securely dated to the period of the New Kingdom of Egypt. It goes very well with the fact that this is the only site in the valley that we have remains of pig bones. The Egyptians are known in this period to eat pig, while the local peoples, not only the Israelites, the Edomites, the local people of this land did not eat pigs. Mostly for ecological reasons. It's not a very good place to raise pigs, definitely not in the desert, but also in other places. It's quite a dry area. So the taboo on eating pigs, it's a big question when it became a taboo or not, but definitely this is an observation that the local people did not eat pigs. And only one site in Timna Valley, the mushroom site, site number 2, has pig bones and radiocarbon dates and also some Egyptian cartouche. So now we know that the main period of production in Timna should be dated to the 10th century BCE. But what was going on there? First, if Rothenburg was able to convince everybody that it's only an empire that can be behind this amazing logistics and organization of production, definitely that also now there was some political body, some political organization that was behind this activity. And we don't have any empires in the region at that particular time, but only the local people. And now, in addition to the evidence of the mines themselves, which are very impressive, in our excavations, we also were quite lucky to find a lot of organic materials that are there only because it's extremely dry place. Timna is a bit drier than Feinan. It's about, let's say, 20 millimeters of annual rainfall, less than Feinan, and this is enough that we will find textiles and leather and botanical remains that we don't find in Feinan, because usually they decay, and in places like Jerusalem you can excavate for another 200 years and you won't find this aspect of the ancient society. But in Timna, because it's so dry, and also there is a rapid accumulation of industrial waste, it buries. It got buried very quickly. So we excavate the slag mounds, and in between the industrial waste, we find some waste from the mundane life, from daily life, and with some surprising results. Again, I won't go on to all of the finds, but one of the most impressive finds was this little fabric that you can see here. It's only a few centimeters in size. And we work here with experts on ancient textiles, and one particular expert, Dr. Naama Sukenik, who works on ancient dyes, ancient colorants of textiles. And she worked in the lab with gas chromatography and was able to identify the molecules of this dye. And she was able to prove that this is the royal purple. I didn't really believe her first, and we had to do the experiment again, and then they didn't believe the date, so we could date this directly because it's organic material. So it's 10th century or late 11th century evidence of the use of royal purple, which was the most expensive dye stuff in this period, or in general in antiquity. It was produced from endemic sea snails of the Mediterranean Sea. It is described like the color for by Roman historians in the Bible as the color of kings and priests and the elite of the society. So we have here a direct evidence for elite in the mines of Timna from the 11th, 10th centuries BCE, the period in which we are talking about the kingdom in Jerusalem of David and Solomon. The bottom line is that in the waste files, we have clear evidence for elite that was associated with the copper, with the metalsmiths. Always when we talk about ancient metallurgy, there is a big confusion between what Thomas is doing, the mining archaeology, and the smelting aspect. These are different tasks. The mining is simpler technology and the smelting is much more advanced technology. It's different people. When people call this site Slave Seal, for example, a miner's camp, it's not a miner's camp. It's the smelters. It's different status in the society that was working there. The miners were probably the lower tier. They were sleeping in tents somewhere, and here we see the elite. Anyways, we have evidence for a stratified society. We are talking about major activity in this period, and you can see here in the map the location of Timna according to the biblical description of the region. So Timna is deep in the land of Edom. Edom is a very famous kingdom that is always in kind of peace and battle relations with the kingdom of the Israelites. So this is the land of Edom, and the biblical description that is related to that is from the book of Samuel, telling us that David became famous after he returned from striking down 18,000 Edomites in the Valley of Salt. The Valley of Salt is, of course, the Dead Sea. So we can see the region south of the Dead Sea somewhere. He put garrisons throughout Edom, and all of the Edomites became subject to David. So now, until the recent research of Tom Levin, Muhammad Najjar in Feinan, and the dating of the mines there, and our research in Timna, there was nothing in the region that can be dated to this period. Not only that we have people there, we also know that they engage in one of the most important activities of the period. And we have a reason for David to go to this remote place to fight the Edomites and to put garrisons all over the land. You cannot exaggerate the importance of copper in this period. It was the source for as in the shape of bronze. They mixed it with tin and got bronze and made agricultural tools and weapons. It was like oil of today, very important material. And also, and this is related to King Solomon's mines, Solomon is described as one that used huge amount of coppers for the construction of the temple in Jerusalem. So the pure copper was related to the construction of the temple, and the Bible doesn't say from where this copper is coming from. And the Bible also doesn't mention King Solomon's mines, which is kind of interesting if you want to go into details. We don't have explicit reference to Solomon's mines. It became a catchy phrase because of the adventure book from the 19th century and the movies, the Hollywood movies, which are talking about gold and diamond mines in South Africa. It's not related. But anyways, the point is that now we do have evidence that the Arava could have been a source for wealth for Jerusalem. The dates are quite clear. The most active period in the history of the Araba, from the beginning all the way to the modern period, was the time of King David and Solomon. Nobody is arguing about that. If there was indeed connection to the kingdom in Jerusalem or not, we don't have any direct proof. We have trade materials that came probably from the hill country, from the area of Jerusalem, like grapes that are not local and many other things. But we don't have any inscription saying that these are King Solomon's mines, so everybody is still discussing this possibility. By the way, for King David or King Solomon, or the author, the biblical author, to mention the subjugation of the Edomites, it's enough that Edom paid some taxes, a few ingots every year to Jerusalem, in order for them to be depicted as subjugated to Jerusalem in the Bible. We don't have to find a stone-built fortress with Jerusalem pottery in the middle of the desert in order to prove it. Okay, we are talking about peoples. Thomas mentioned this as well, from a nomadic origin, the 12 tribes of Israel and the tribes of Edom. It's all related to a tribal society that got together, created some kind of a tribal confederation, and went together and accumulated power and created kingdoms. The transition into sedentary life took many generations. This is something that many scholars were not aware of. And for them, in the minute they became kingdoms or whatever, they were completely settled. And this is, I think, a Western bias of looking at these mobile people as always people that have to be in the margin of society, slowly nomads. This is something that I've been working on recently, the methodological questions of how us archaeologists translate the finds into history. And it is a very challenging task, especially when we talk about mobile people that we usually don't see. Here we have an exceptional case in which these nomads engaged in copper production, so we see them. I can tell you there was a confederation of tribes that created a kingdom of some sort in this period only because they engaged in copper production. We don't excavate their houses because they didn't live in stone-built houses. We don't excavate their tents. We usually don't find them, and sometimes if we do find them, it's very hard to date tent remains. So this is all related to methodological questions, and the bottom line here related to this issue is the search continues. The discussion continues, and I do believe that we have very strong evidence for at least the possibility that this was the main source of wealth of Jerusalem, and this very important period in the first days of the ancient Israelites as a kingdom. Now I want to continue and to zoom in into these 500 years of continuous copper production in the Araba. Okay, so we have, after many years of the work of Tom Levy, Mohammed Najjar in Feinan, and after our work in Timna, we now know that there was a continuous production in the region, starting with the Egyptians. It indeed started with the Egyptians, and it actually intensified after the Egyptians left. They left because the big crisis of the end of the Bronze Age. Probably you all have heard about the big crisis of the end of the Bronze Age. So the Egyptians one day did not come to the region. But the local peoples that worked under the Egyptians learned, emulated the political mechanisms of the Egyptians and created their own polity to continue and work the mines all the way to the late 9th century BCE. So we have here an example of 500 years of continuous production in which the dating resolution and the work on the slag and the work in the mines can give us very interesting insights about technological developments in very high resolution. How people invent, improve efficiency, how inventions are coming to be. All of this kind of interesting stuff that now we are going to discuss and for this 500 years. And I mentioned this recent paper with friends here in the Bergbo Museum, Michael Bode and others, in which we were using remains from this, also other periods, but mostly from this specific period of 500 years, the slag or drills, remains of things related to the technology in order to establish the chemical signature of the metal of the Araba. So this helps scientists or archaeologists to identify Araba copper in other places. It's very important. The group of Bode and Kiderlen, for example, quite a few years ago, were able to show that in this particular period, 10th century, 9th century BCE, the copper of the Araba went all the way to Greece. They analyzed copper from Delphi and Olympia and were able to show by the chemistry of the tools that the copper in the Araba was not only for local consumption. It went far away. And since then, there were other studies showing a similar trend. So for a certain time in the history of actually the Eastern Mediterranean, the Araba was the major supplier. So now we want to zoom in into the technology. And this is summarizing a paper published in 2019. Which is the accumulation of many years of work, ancient technology and punctuated change. It's all related to also the story of the emergence of the Edomite kingdom. We're going to say a few words about that. But you see here the ore, the green stuff, how it became copper. So you see, Feinan and Timna, there is a major difference in general in the ore they were using during this period. Okay, the Feinan ore is manganese rich and the Timna ore is iron rich. We have some differences like that in that, and in this particular period, the smelting process was very sophisticated. It was not enough to put in this green material. They knew that they could add another type of material in order to make the process more efficient. This other material is called flux. They mixed it with the copper ore. It enabled the reduction of the smelting temperature, and it made the slag less viscous. So the separation between the metal and the slag is much better. Anyways, just remember that in this particular period, the smelting was really advanced and they were quite smart about it. And it is related to the results that we have. And one of the questions that was interesting for us to check is if the evolution of technology is gradual or is it punctuated? I would try to tell you why is it important to the interpretation of the results that we see. This is the whole point of what I'm going to try and say and convince you about. Okay, so technology can develop gradually. Every time there is a little improvement and everybody's happy and it develops in a linear way. But it can be also a different model that you can see here, the punctuated equilibrium model, and it's all taken from, of course, biological evolution. I won't go into that, but this is the other option, that there is kind of almost, we call it quasi-static situation in which the improvement is not very impressive, maybe even not improvement at all, and then there is something and there is a leap in technology. These are the two models that we wanted to test in these 500 years of continuous technological development. This is one of the major results of this project. It's dozens and dozens of pieces of slag that were taken from well-dated contexts. So you can see that on the top, on the x-axis, is the amount of copper in the slag, between 0 and 2.5% weight percent. Of course, the less copper we have in the slag, the process is more efficient because they were able to extract more copper and make it into metal. Okay, so and here you can see the dates in this curve from 1150 BC all the way to about 150 BC. Okay, these are the slides that we were using. And you can see a general trend of improvement in the efficiency of the smelting process, right? From an average of about 1.7, 1.8, 1.65 actually % of copper to an average of 0.5%. So there was an improvement in the technology all the time based on different mixtures of flux and ore and charcoal and et cetera, et cetera. But we also see that the transition between this period and this one is very sharp, especially in the standard deviation. You see the standard deviation here, it's much, much smaller. So they suddenly started, in the most efficient technology, they started following a very specific smelting protocol that was very identical between one smelt to the other. Okay, so there is actually some kind of a technological leap here that we can see in other things as well. Okay, we call it the technological leap or the punctuation event. So there is kind of a gradual improvement, but then there is an event of technological leap. We can see it also here. This is the general composition of the slag from Feinan only because it's the manganese-rich slag. Anyways, all of this, the purple ones are more concentrated and closer to the better temperature for an efficient smelt. And you can see nicely, these are ordered by the date. That after the leap, the technology is more efficient. We can see similar thing in Timna. Timna, in the layer before the leap, this one, the deeper layer on side 30, you see that the flux was iron. The slags are rich in iron, almost 40% iron, because they were using iron oxides as a flux. But then there was a major change, and the upper layer, they switched to a different flux, which is a manganese-rich slag, manganese oxides. So there is a major change in the use of flux in the south only. They learned from somewhere that manganese is a better flux than the local iron, and they started mining manganese oxides and added it to the smelt. Okay, I hope you are still with me. But the point is that there is a major leap in the technology, and we can see it even in the installations themselves. tuyers are a sophisticated device made of clay, which connected the bellows to the furnace. It was the most important part of the installation because it protected the bellows that were made out of organic material from burning and getting destroyed. So there is a major change in the size of the tuyer and the size of the furnaces themselves. Okay, so there is a technological leap here, and the dating is very good. You have, I think, hundreds of radiocarbon dates. And we connect it to an external event, which we know about from Egypt. The famous temple in Karnak tells us about the campaign of Pharaoh Shoshenq I, and we know about this campaign also in the Hebrew Bible. The Hebrew Bible tells us that 5 years after the death of King Solomon, an Egyptian pharaoh came to the region. He made a siege over Jerusalem and took many of its treasures and things like that. He didn't conquer Jerusalem. We hear in the Bible a very interesting story. And in the Karnak inscription, we know that one of the military companies went to the region of the Araba. Until these recent years, we didn't know, again, what Shoshenq I had to do in the Araba, but now we know that the most active period of the mines is exactly that time period. And Shishak went to the Araba, and now I will try to say why is it so important to analyze all of that in the punctuation change model, because Shishak, this is the temple in Karnak, mentioning the sites of Shishak in the Negev, etc. The date is about 925. We are not sure about the exact date, but it's very much in agreement to the radiocarbon dates that we have. And recently, not so recently anymore, but a student in a field trip 10 years ago or so found a scarab with the name of this pharaoh Shoshenq I in one of the smelting sites in Feinan, which is quite incredible. There is only one more inscription of this pharaoh outside of Egypt in Megiddo, and the other one is deep in the desert in the Araba. So now there is quite an agreement that this Shishak went, you see the black lines over there, that he went to the Araba. And of course, he didn't want to destroy this industry. There was no interest of Egypt to destroy the thriving industry of the Araba. He just wanted to make sure that the copper of the Araba gets to Egypt, that Egypt continues to get copper supply. This is the 22nd dynasty of Egypt. This period is famous with bronze artifacts. The metal industry was very active in that time period. Egypt was not an empire anymore, not like in the days of the New Kingdom, but it was, it was still there and it still needed copper. So this connection of the Shishak and the Araba is quite clear. And we believe that Shishak is responsible for this technological leap. You can see it also here. You can't read anything, of course, but this is just all the types of activities that are required to make a successful copper smelting. All the way from the beginning, from the production of charcoal, the mining of ore, the mining of flux, the building of the furnaces, the building of the tuyers, and the building of the bellows, the supply of water, the supply of food, the management of all the work, the end process. You had to break the furnace, you had to crush the slag, you had to take the copper residues in the slag, to remelt them, to melt them and to cast them into ingots, to take the ingots back. All of this, it's a massive organization. And this is organized by the period. So it starts with the Egyptians, so just after the Egyptians are also here. And then this is the leap. And the change in all the red stuff here are changes in this organization. And the point is, and I think it's an important and interesting observation to anyone who works with ancient technology, is that in case of a sophisticated technology, of a complex technology with many different components, the technological development will always be limited. There will always be some constraints on the amount of development that this society can take. So this is why before Shishak, we see only gradual development of the technology, and you need something to shake the system in order to get a technological leap. This is why we need the Egyptians in the picture. It doesn't mean that Shishak himself came all the way from Egypt with all the technologies. Probably in Egypt itself, in the Nile Valley, we don't have smelting technology. But he came with a military force and shook the system in a way that available technologies that were invented here and there were able to be implemented into these complex systems. Imagine the group that mined iron oxides in Timna, for many generations. So even if people somewhere heard that manganese oxides is much better, they won't easily replace their trade. They won't easily start exploring the manganese oxides. It's not going that easy because there are many people involved. They are used to something. And if somebody is used to something, you know how hard it is to convince them to do something else. You need an external force to say, enough, manganese is much better, reorganize the system. We are using manganese ore in Timna. And this is how the metallurgical technology, the big change, could have been implemented into this complex system. And I think it's true, or can be true, to many other complex ancient technological systems, that even if some invention is available, it's not necessarily immediately adopted by other group. There is a complex system here, and this as more complex the production, the technological system is, it's harder to change it. And an example from this period is something that is maybe easier to understand, because together with this event of Shishak, there was another technology that changed abruptly, like that. And this was the technology for transportation. The technology for transportation. So until Shishak, all of these sites and remains, we find only donkey bones. So for years, they were using donkeys to do all the hard work, or also mules probably, but donkeys. And then a few sites, the production was more centralized. Only in the sites that continue after this leap, in the new reorganization of the system, this is where we find camel bones. And we published it, it was about a few years ago, together with an archaeologist that I work with, and it made the news that the camels were domesticated in 925 BCE. And of course, it's not the case. Camel domestication, it's a long process. It took generations. And it probably happened a few generations before, maybe even 200 years before in the Arabian Peninsula. But for many years, even though the people of the Araba heard about maybe this new technology, the local donkey riders did not allow these camels to come. It's like the situation with Uber in Israel. There is no Uber in Israel because the taxi drivers have a lobby, and every time somebody tries to put it in the system, they just go to the Knesset and they really stop this process, and we just don't have Uber. So back then, they didn't have camels for many years until there was something that shook the system, and this new technology could have been adopted. So this is the idea behind the technological leap, the punctuation event that is relevant to complex technological systems like copper production in the Araba, and I think it's relevant to also other ancient technologies. So I think that's the main points that I wanted to share with you today. Thank you very much.